Again, thank you so much for having me. So I'm a PhD candidate in Claudine Gauthier and Louis Barrere's lab. And this will be one of the chapters for my thesis. So as we know, aging is associated with a cascade of declines to the vascular system, which can be accentuated by obesity and physical inactivity. And over time, these declines can lead to gray matter atrophy and sometimes eventually cognitive decline. Now, importantly, more males experience age-related cognitive decline and at a faster rate than females. And why this is important is because when we look at the literature, we see that there are apparent sex differences in the rates of decline of gray matter volume across not only the lifespan, but when we take a look at older females here compared to older males, we actually see that older females have significantly greater gray matter volume. And it's possible that sex differences in gray matter volume are driving, in part, some of the sex differences that we see. The question then becomes, if we know, according to our little figure here, that gray matter atrophy is related to cognitive decline, then why do not all people develop it? And is there a sex-specific role, knowing that males tend to have greater age-related cognitive decline than females? So there's obviously been a lot of work into this, especially because we know that generally speaking, generally speaking, not all individuals experience cognitive decline. And in fact, almost more than 50% of people over the age of 60 don't experience cognitive decline. So why is it that some people experience it and others don't? Now, of course, there's genetic differences and lifestyle factors as well. So in terms of lifestyle factors, we see that obesity and physical inactivity are two of the top rationales for why some people develop dementia. And when we look at the literature into gray matter volume and obesity, which can be indicated by increased BMI, we note that increased BMI is associated with decreased gray matter volume. But others have actually found absolutely no association between gray matter volume and BMI, or a positive one. And this begs the question of, are sex differences driving this lack of association? And Taki and colleagues have actually found that there are sex-related differences, where they only found males to have these significant declines associated with gray matter volume and BMI in these blue regions. Now, they also did note some positive relationships where those with higher BMI had higher gray matter volume within these regions. Other work, more recent work, has actually found the same in both males and females, where those regions in green are the regions that actually have this negative association with BMI, and then the regions in red have this positive association with BMI. Now, they did note one sex difference where males actually had significantly decreased gray matter volume within the anterior cingulate cortex. And this anterior cingulate cortex also comes up when we look at physical activity. And in terms of physical activity, the seminal work by Kulcomb and colleagues in 2006 found that individuals who had higher levels of physical activity actually had higher volume in the anterior cingulate cortex, as well as the temporal and frontal regions. Now, this has been replicated numerous times, I would say close to 100, if not more, in about the past 20, not even 20 years, 15 to 16 years. And what we see again when we take a closer look at the literature is, yes, physical activity is good, but sometimes studies are reporting sex differences, where, for example, in this study, we see that females are experiencing the benefits of physical activity on their hippocampal volume, but males are not. But on the flip side, other work has actually found that the males, as indicated in blue here, actually have a more significant relationship between physical activity and volumetrics, particularly within those hippocampal regions. So when we put this all together, it might be that individuals who have higher BMI or higher obesity, we know that generally speaking, they experience lower gray matter volumetrics. But on the flip side, we have those who are more physically active and they have higher gray matter volume. So one could postulate that if we have somebody who has obesity but is physically active, perhaps the amount of gray matter atrophy that they experience is actually significantly less than somebody who has a high BMI but low physical activity. And in fact, research from Dr. Barrow's group we found that in cognitive outcomes, our higher fit obese individuals have significantly better cognitive performance than their low fit obese counterparts. But to date, no one has actually investigated their interaction on volumetrics or any imaging outcome. So that was our purpose here. For the purpose of this presentation, I'm only going to report on gray matter volume, but we wanted to identify sex-specific relationships between gray matter volume and BMI, as well as total and moderate physical activity, and then the interaction between the two. So we had a sample of over 400 participants, where study one, it was 2 studies put together, and the first were very healthy, had no underlying conditions or medications that they were on. So a very, very, very healthy aging group. And then the second sample is from the Prevent AD samples. So they investigate individuals that are at a high risk of developing dementia due to familial risk factors. So as we can see, when we collapsed both studies together, but then separated them into sex, generally speaking, males were more well-educated, had decreased global cognitive status as indicated by the Montreal Cognitive Assessment and Mini Mental Status Exam. And they also had increased cardiovascular risk factors indicated here, as we can see by their blood pressure, BMI, and Framingham risk factor scoring. So all participants underwent an MRI scan on a 3T Siemens scanner in Montreal, and an MP range, among other scan sequences, was acquired in all individuals. And this allowed us to employ voxel-based morphometry to extract gray matter volume within these participants. So just briefly, all MP range images were registered to standard M&I space using ANTS. And then once in standard M&I space, we extracted gray matter volume using an atlas within the frontal, temporal, parietal, insula, and hippocampal regions. Now from here, we took these gray matter volume region of interest, and we put them into a sex-specific polynomial regression, where we wanted to investigate specifically the relationships between gray matter volume and BMI, so body mass index, which is a standard outcome looking at kilograms of someone's weight divided by their height in meters squared, where higher BMI is associated with increased adiposity or increased obesity. Then we also looked at physical activity and moderate physical activity. So in our study one, we actually had participants complete a VO2 peak assessment, which is the gold standard for cardiovascular fitness. Now, unfortunately for the Prevent AD data set, we did not have this, but we did have a physical activity questionnaire where individuals gave us detailed information on the past year of their physical activities that indicated the type of activity, the intensity of that activity, how often they were completing it on a weekly, daily, and monthly basis, as well as how often per session. And based on that, we used the physical activity compendium to create metabolic equivalent minutes per week. And then we looked at the interaction between the two to see if physical activity was somehow modulating these relationships between BMI and gray matter volume. As a quick side note, we did use age, education, study, and Framingham risk factor scores as covariates. BMI, physical activity, and Framingham scores were converted to Z scores for the purposes of our samples were clearly different, where we had super healthy older adults, and then we had individuals who were not quite as healthy and more representative of an aging population. So to be able to compare them and put them together, we decided to use Z scores. So when we look at the results that our females had in terms of BMI and gray matter volume, where on the x-axis we have BMI and on the y-axis we have gray matter volume. And in this first panel here, we have healthy weight and then overweight and obese, just to give you an idea based on their BMI rating. We actually see that as females increase weight and become overweight, they have significantly better gray matter volume as we move along this green line here. And as they continue into obesity, they lose those benefits of being overweight. So this rate here has actually been fairly well documented in aging, and it's known as the obesity paradox. So briefly, it's just that as we get older, it's actually better to be slightly overweight, if not slightly obese into aging, because it's either protective, or if an individual is on this end of the spectrum, it could indicate that they are already on their way to developing dementia. And we did see this throughout numerous regions in the brain, including the parietal gyrus, as I've shown here, the temporal gyrus on bilateral sides, as well as the medial temporal gyrus. And when we look in relation to females' physical activity levels, so their total physical activity levels in the gray matter volume, we see that as an individual's total physical activity levels, so that means anywhere from light to intense physical activity, as that increases, we see significant relationships with gray matter volume within the medial frontal gyrus. And this was the only region that we actually saw this relationship with for total physical activity. Now, when we looked at moderate, which is just moderate to intense activity, so something that would be much harder than a brisk walk, we found actually this inverse U shape again. So a quadratic polynomial where as individuals increase their moderate physical activity levels, their gray matter volume significantly increased to an extent, and then we almost see like a tapering of the effect of physical activity. And we saw this not only in the medial frontal gyri, but we also see it in the left superior frontal gyrus, and the left superior temporal gyrus. So then when we looked at BMI and the physical activity interaction, we see, again, we've got our BMI now back on the x-axis, still have the gray matter volume on the white, and those panels according to BMI. But now we have this added 3 levels of physical activity, where the red line indicates those with none to very low levels of moderate physical activity. The green line is medium, and the blue line is high levels of moderate physical activity on a weekly basis. So we see that across the BMI spectrum, regardless of healthy weight or overweight or obese, it's actually better, indicated by the blue line again, to be more physically active than to be not physically active at all or a little bit physically active. And it looks like, when we compare this to just the BMI, that the lines are actually increased a bit. So physical activity is having some sort of a protective effect in females. Now, polar opposite, for the males, we actually found that as males have increased BMI, their gray matter volume decreases. But this was only found in the parietal gyrus. When we looked at physical activity outcomes, we did not actually see any relationship between males in gray matter volume and physical activity. But when we looked at the interaction between gray matter volume and BMI, we found, again, the opposite of what we found in females. So again, the same colors, the same graph, generally speaking here, except this one in males shows that males who are healthy weight with high levels of physical activity actually had higher gray matter volume, whereas if they were healthy weight but had low physical activity, they had the lowest gray matter volume. And then we see them kind of intersect and go in complete opposite directions, which is completely opposite to what I hypothesized. Now, this could be in part because it is a smaller sample, and we do have, 2, potentially 3 big outliers here, and my graphs are showing the covariates essentially out. So when I looked at these 2 participants, they had very good Framingham risk factor scores, so they were some of the lowest, even though they were obese. And they also had they were not as old as the rest of the sample and fairly high educated. So those things might be why they're protected against obesity. And apparently physical activity here just doesn't have as much of an impact on our males, at least in this sample. So all that to say, we clearly find that males and females are very differently influenced by obesity in this sample, where we find the opposite of what the literature has previously found, where generally females have a negative association with obesity and gray matter, and males have an inverse U. Now, when we took a closer look at the sample and previous literature, we actually found that previously, it was actually the females in these manuscripts that had worse cardiovascular risk factors. So they had more risk factors and were overall more sick. So here we kind of have the reverse. So it kind of makes us think that it could be due to a difference in metabolic risk factors, because in and of itself, obesity is not actually bad for your metabolic or brain health, but it's the consequences associated with obesity. So high blood pressure, diabetes, etc., because these comorbidities are actually associated with inflammatory markers, which tends to be more associated with negative metabolic and cerebral health. Generally speaking, we did see that females were protected with greater amounts of physical activity, where across the BMI spectrum, only in females, we saw positive associations with physical activity. And this confirms a previous meta-analysis that showed in cognition, only females benefited from physical activity. And I think what was super interesting about this, for me at least, is that our total physical activity showed a linear relationship with gray matter volume, but our moderate to intense physical activity has an inverse U shape. So it indicates that there might be some sort of beneficial threshold where more physical activity is good until an extent, and then after that point, there's no more benefit for moderate to intense activity in females. So quickly, some limitations. This is macrostructure data, and specifically only gray matter data. And we know that this can be quite an ambiguous outcome. Our females were significantly healthier than the males and more active, which is completely against everything in the literature so far. And going along with this, we had a very small sample of males compared to females, so we could have been underpowered to see overall outcomes. And finally, BMI, although a measure of overall adiposity, is not a measure of central adiposity. And we know that central adiposity or obesity is actually more associated with negative metabolic health and brain outcomes, given its relationship with different storage of fats. So future work should definitely investigate other parameters such as cerebral perfusion, white matter lesions, which we're looking at just not in this presentation, as well as microstructure, peripheral inflammatory markers, as well as the type of adiposity and where individuals store fat and the type of fat. So overall, this highlights the importance of sex-specific differences, particularly in aging on cerebral health. Importantly, physical activity influences the relationship, whether or not it's for better or for worse. I think it could depend on your sex, but we would need a much larger sample to even begin to stipulate. And again, like obesity and physical activity definitely change across the lifespan in terms of their relationship with the brain. So we're just capturing a very tiny window here. So it's possible that these are not the relationships that we would expect outside of the 60 to 70 range. So lifespan studies are therefore imperative to further understand this relationship. And with that, thank you so much for your time, and thank you to both my labs and all the collaborators.